All right, great. So this is meeting 8. Today is November 11th, and we're going to talk about what could go wrong. All right, so an overview. So actually, before we get into that stuff today, I'm going to give some reminders, track updates, and project updates. And then, as I mentioned a minute ago, we're going to go into several different projects and systems that we've worked on that there's been some mistakes, some issues, some stuff that's gone wrong. Nathan's picture here is great. You can tell that I'm unamused by the system here. I didn't actually know this picture existed until now. Those rods are supposed to be straight, and they're not. And the air did that to them. Like, not like hitting the ground or like someone hitting it with a hammer, like just air. Because the rocket experienced that catastrophic of a failure. So, yeah, stuff happens. All right. So I just wanted to give a couple reminders beforehand. I think there might have been a little bit of confusion about this. I just want to make sure that we're clear. So the first thing is that the point of these presentations is not for you to remember all of it. Like, please don't stress yourself out about that. It's really just to expose you guys to the concepts and the content. You're not supposed to become an expert. You're not supposed to remember all of it. Not like even all of us remember all of it. And I put that on there that like there's a reason we rotate through, right? I mean, some of us know, some of the topics, some of us know others of the topics, and we rotate through so that you guys can hear from multiple of us, but also so that you guys can hear from the people that know some of these subjects the best. And so like don't assume that we have all of the answers. We're learning just like you guys are. We've been doing this for a couple of years, but we are far from experts. So you are not expected to become an expert overnight. Your mentors are here to help with specific questions. Really, the point of the PowerPoints is just to give you guys exposure to the concept so that you know what questions you can ask. Maybe we mentioned something and you don't really understand what we were talking about, but now that's a question you guys can ask us or you can look into or anything like that. So just wanted to make sure that was clear to you guys. Don't worry about this. Another thing, a lot of you guys have been doing this, so if you have, that's great. But if you can't make a meeting for some reason, that's fine. Just let some combination of me, your mentor, and your group know if you can't make it. If you tell me, I'll tell your mentor and your group. It's great if you can also tell them, but you don't have to. If you tell me, it will make it to those people. So yeah. If another thing I wanted to mention is that we mentioned this in the initial poll that we put out for you guys, and we haven't really talked about it since. So I just wanted to kind of reiterate on this. If you're willing and have time outside of these Wednesday meetings that you want to get together or work on this stuff, do some research, by all means do so. Definitely prioritize school. I get it. We're in the middle of midterm season number 2. So like if you're super busy and can't, there's not an expectation that you are, and that remains the same. And we've been saying that all along. But if you do have time and you are interested, it's definitely something that you will get benefit from continuing to put time to this. And it can be really rewarding and propel you guys forward. So if you are interested in that, I would definitely encourage you guys to have conversations within your group about where you're at, where you're trying to go. If you guys can do additional meetings, you can talk to your mentors about that. I just want to kind of bring that up so you guys know that is an option and is something that we support. All right, track updates. So we're hoping to kind of get back a little bit to the half an hour presentation. That's kind of our goal, to give you guys a little bit more time to work in teams. So just wanted to let you guys know that we realize that you guys have PDR coming up soon, and so in order to give you guys an opportunity to make sure that you can get your stuff done for then, that we're going to try to get you guys as much time as possible in meetings to work on your stuff. The remaining schedule in terms of this semester, which is kind of crazy that we're already coming to the latter half of this, is this week we're talking about what could go wrong. Next week we're going to talk about different manufacturing methods that includes additive manufacturing. The week after that's Thanksgiving, so we're going to have a really big meeting. We're going to move it to Thursday instead, so that you guys can spend Thanksgiving with us. No, I'm kidding. Enjoy your week off. We will not have a meeting Thanksgiving week. The week after that, we're going to be talking about design review information. And then the week after that, which is the last day of classes, we will be having you guys present your PDRs.
That does look really nice.
So,
off from $50.
What's that? Can you guys mute, please? And one other update on that front, with speaking of PDR, is we talked over the weekend, the mentors and I. We discussed what we want you guys to have for PDR, and we'll go more in depth. And you guys can ask your mentors if some of this doesn't make sense or you're still kind of unsure. But we didn't really give you any information yet, and so we just wanted to kind of put the bug in you guys' ears so that you know what we're thinking. So initial ideas, initial concepts, thoughts. You guys have already been taking notes. Your need, want, nice to haves, all that stuff. That information's great. We want to see that. Another thing is design matrix or design matrices. We've talked about this before, some, and I think you guys are probably starting to get near doing those. So if you guys do any analysis like that, definitely include that. That stuff's great to see. A nice, mostly to scale system sketch or block CAD if possible would be awesome. We refer to block CAD as certainly it's CAD that's not perfectly fleshed out, and it's not necessarily like every screw in there or all the parts might not be the actual parts, but it's like a representative model that shows the rough architecture and the way that the system looks. I realize that's going to be a stretch goal. A lot of groups are not going to be able to get to that. Some groups might. That's kind of a best case scenario goal, I think, for you guys. So if you guys can get to that, that would be awesome. I understand if you can't, but at the very least, a system sketch would be super helpful to us just to understand what you're thinking of. Your design matrices are going to help you figure out what you want it to look like. And then if you can do a sketch that just kind of takes that decision and translate it into something that we can see, who hasn't been involved in your entire design process, that would be awesome. And then the last thing is some feasibility checks with supporting evidence. So, if you're using, let's come up with an example that you guys definitely won't do. If you're using a rocket to launch your projectile 15 feet, which is against the rules, which is why I'm picking it, you would show that the energy in the rocket motor is enough energy to move the projectile to 15 feet if launched at some set angle or something like that. That's the sort of feasibility check. Or if you're sourcing some component, you need I guess a spring, to confirm that that spring is a real thing that exists. You don't have to pick the spring you're going to use, but to just make sure that you didn't choose something that requires a battery that's the size of my bedroom. Making sure that we have something reasonable. That's what the feasibility check means. And again, if you have any questions on stuff like this, you can ask your mentor, and you don't have to actually worry about putting this PDR stuff together yet. We're going to do that after Thanksgiving, but I just wanted to let you guys know where we're hoping you guys are at by the end of the semester, so you guys can think about pacing and such accordingly. As usual, I wanted to go over if there's any group changes. We actually are going to do a group change this time. We didn't last time. The only thing is I've folded both of Emma's groups together into one big group. It's my understanding that you guys have been meeting as a pod the entire time anyway. It honestly just makes sense at this point just to have you guys work together as one group. So this just reduces the need to change anything. You guys can continue to work as you have, and hopefully should allow you guys to delegate work and get stuff done. So yeah, so you guys are a group of 5 now, and nothing else has changed. So that's that. Yes, more project updates. So you got actually also, if you guys have any questions, feel free to interrupt me. I'll stop in a bit, but I'm also going to stop now real quick if you guys have anything. I realize I'm throwing information at you guys. We good?
Do you guys know where to find the PowerPoints? If you want to go look back.
That's a great question.
That's kind of important. Here, I'll stick the link in the Discord.
Yeah.
Yeah.
There's a folder with all of these. These are intended to be a resource that you guys can continue to reference. So
I kind of hope you're not taking notes ever.
Please no.
I mean, that sounds like it's not going to be any fun for you, and you're just going to stop doing it. So yeah.
I can tell you that
if
I
you
wouldn't
enjoy
take
taking notes.
Yeah,
then
totally.
take notes.
If you want to, you can. But personally, I would hate taking notes for a club and would probably stop doing that club if that was expected of me. So I am certainly not going to expect that of you. Like, really. The, like,
I will, but Scott won't.
the absolute last thing that I want you guys to feel is that, like, we're professors lecturing you guys. You guys deal with class enough. Like, I don't want this to be like class. That sucks.
No, it's more like we're TAs lecturing. It's a lot more casual. And that was a joke, to be clear. We don't equate us to TAs either. We care a lot more about what we're doing than a TA.
Shots fired. Oh, I went too far. Yeah, so last thing on project updates before we get into the mistakes we've made is electronics. I was asked about this stuff last week by a couple of groups. I wanted to give you guys an update. So at least as of now, I guess I'm going to add a disclaimer that technically it could change, but it probably won't. We're probably going to be using Arduino Nanos for the main control board. For motor controllers, if those are necessary for the stuff you guys are doing, we'll probably use the L298N motor controllers. Those for the little brush motors that we'll probably be using can do 2 each. And then we'll be using 18650 Li-on cells, quantity TBD, but for battery. I will let you guys know what you can use in terms of number of those. But hopefully, you guys don't have to worry about doing software and electronic stuff yet, but I'm hoping that this will allow you guys to get a better idea of what space claim you might need to allot for that stuff. All right. The last thing is budget. So I also kind of owe you guys information on that, and I'm not going to give you exact numbers yet, but I just want you guys to know that you can assume that you can spend on the order of $250 to $300 on top of club hardware, stock, etc. So that's going to include both the whatever COT stuff you want to go out and buy, and then that's also the list of pre-purchased items. So those 2 categories will fold together to be on the order of $250 to $300. That doesn't include the projectile. That doesn't include the prototyping budget. Those will be additional. So yeah, that doesn't include the batteries. That doesn't include the main board, anything like that. Even stuff like wires. We'll cover all that. That's really more for you want a motor, or you want a spring, or you want something that's very specific to your design. That would come out of that money. And the only reason I tell you is just so that you can keep that in mind. If you design something that requires a $1,000 component that you can't get for cheaper than that, well, we're probably not going to be able to make that happen. So, yeah. Okay, the fun part, where we get to make fun of ourselves a little bit, but all in good fun. So we want to discuss a few of the many times that we've made mistakes in the past that have had small or large impacts on the project. And there's some key takeaways, and different ones have different takeaways, but that I wanted to emphasize. The first is that we mess up a lot. Really, I'm not just saying that. We legitimately make our fair share of mistakes all the time. And that's okay. I say that not to put us down. by we, by the way, I mean the mentors, but also probably every other engineer. This is a profession where you're on the the cutting edge, or you're doing something new, or if you're designing something, it's probably because it hasn't been done that exact way before, or it costs too much money or something like that. So when you're doing something new, you're gonna make mistakes, and you're gonna run into issues, and that's okay. It's a part of the job. It's also how we learn. A lot of the stuff we're going to talk about in here relates to the club. Some stuff doesn't, but this is all stuff that this group of mentors and the other people that we've worked with in the club have done, and it's a big reason why we know the stuff that we do today. So as we're teaching you guys stuff about stuff that we've done before, different mechatronics concepts and all that stuff, we've learned all of that through these mistakes. I know it's super cliche, and you might be rolling your eyes, and I'm not going to blame you if you are, but it's true. Another thing is there's no stupid ideas. Even the ones that are your ideas that you think are stupid, which are often the stupid ideas that don't come out, never leave your head. Say them. Say the ideas. I can't tell you how many times the final solution to a problem we've had has been begun with the disclaimer of, I really don't know if this would work, but I don't know. What about this? And I've, over my time doing this through college, I've tried more and more to spit those things out, because even if that isn't the answer, maybe that can become the answer. I can think of times literally in the last couple of weeks that Peyton and I, while talking about capstone stuff, have had conversations like that have been like, I really don't know if this would work, but what about this? And some of them have turned out to be, ridiculous, and it won't work. And a couple things, sometimes it is the answer. So, or it leads you there.
We recently had a string of two of those in a row, where I spit a crazy idea out, and then sort of got everyone on board, and then immediately had another idea, shifted things all the way back in the other direction. And it sounded crazy because I had just, made a really good case about why we should do the total opposite thing. But, when you just talk about it, when you generate conversation, it really helps.
Yeah. Then the last thing is about breaking stuff. Much like making mistakes is a part of the process, the process, breaking stuff is one of those mistakes that's part of the process. You're probably going to break something, and it might not be cheap. It might be cheap. That'd be great. But if it's not, okay, fine. We'll live with it. I've broken stuff that's expensive, that takes time to replace, that I've worked really hard on, and now it's, I did something dumb to break it. It happens all the time. It's okay. Let us know. Don't be worried that we're going to be mad. We're not going to be mad. It's fine. Let us know. We'll replace it. If you break your Arduino when you get it, okay, fine. So don't be nervous to tell us. We're not going to be mad. We'll get you a new one. The worst thing you can do is not tell us, because then you're stuck with broken stuff, and you probably need that thing to be working to continue progressing. Time in this club is honestly our most scarce resource and our most valuable resource. I think that everyone in this call would probably agree with that. Clubs generally don't have clubs generally or try to scrape together as much money as possible, because money is often their scarcest resource. And with any club, this one included, that's a factor, of course, but sometimes it is worth it to just spend the money to save the time, because the time is really valuable to us. So really don't be nervous to tell us if something breaks.
If you break your Arduino Nano, that's literally of no significance. And if you break something 10 times that expensive, that's probably of no significance either. Just so you know, this club has a $50,000 budget, and most of the expenses for this track are not even being covered by the club. They're being covered by the Department of Mechanical Engineering. So it really doesn't matter.
Now, that said, don't be reckless that.
Yeah.
But I don't expect that anyone would be I'm not expecting that you're like throwing your stuff against a wall or into the floor. Like, don't do that. But I don't think that you would.
Try not to screw up.
Yeah. All right. So with that said, I'm gonna start. All right. So the Pokeball. Let's see if the video decides to work. Oh my God, it did. Okay. So I think you guys have all probably seen this at one point or another. This is a fun video. This is a thing we worked on last fall. And this is a Pokeball. It was a part of the competition rocketry project, and its job was to hold the parafoil system and eject it, and then control the parafoil as it descended. So it was attached to the rover that was supposed to complete the NASA challenge, and it would guide the rover down to the place where it's supposed to land. And based on the videos you've seen, you probably think that this was, all sunshine and rainbows, and it was not. It took a long time to get here. This video was taken in early December or late November. I think it was early December because this was right before the second drop test.
Yeah, it was like the week before.
Yeah. So, yeah. So I want to kind of walk you guys through real quick the kind of process it took to get here and a couple key mistakes that we made both from a technical standpoint on this and also from my part from a administrative and project leadership or project management role on this, because there were a couple things here, and these are good lessons for you guys to hear about that I learned the hard way. No, go to the next slide. There we go. Okay, so the video you saw before was of Darkrai, and for those of you who are familiar with Pokemon, you might recognize this naming scheme. But before Darkrai was Driftbloom, and Driftbloom was, you can see on the bottom here, these left two pictures were the bottom of the system, and then this is the front looking from the top of the system. And it's the same pusher plate style thing that held on to the parafoil inside of this cavity, and then these elastic cords here would, once the latch on the bottom was undone, would push the parafoil out. So conceptually, it works kind of the same. But the problem is that, as you can probably see from the bottom of this, it's incredibly complicated. And while the theory of it wasn't that crazy, there's a lot of moving parts and a lot of little things that are handling large loads. It's hard to tell from the picture, but these cords, these elastic cords, had a lot of elastic energy in them. And so when this was held back, there was a large force trying to push it up. So yeah, it didn't work. Is kind of the result. We worked really hard on it, and we went to the field to test it, and it bound up, and it didn't work. So we kind of went back to the drawing board, and we spent the next month to month and a half or so putting an increased importance on reliability and ease of setup. Those became kind of our two primary factors in the system, and that made a huge difference. As you can see here, this is the unloaded state, and then I pushed it back, and it's loaded. So that took 7 seconds of video, and the first couple seconds I wasn't actually really loading it.
I think
talking about
it's worth giving context here. It took us 4 hours to load it the first time.
Yeah, that's not an exaggeration. It actually took about 4 hours to load, because everything had to be aligned just right, and the only way to align it was your hands pushing against these super strong, stretchy cords. My hands hurt a lot after that. Yeah, no, it was a disaster. And then those same forces that were hurting my hands were causing the entire system to bind up. Yeah, no, it was a disaster. So we should have seen that coming. I'd worked with systems that had loads before, worked with systems that had small components that, you don't want to rely on a lot of those, but I didn't recognize it, and that's okay. And we learned from it. And what did we do? We turned around in the next month, and, it was the same rough idea. You can see the same style, but we switched out the elastic cord. We switched to these constant force springs. We used an electromagnet on the bottom instead of that complicated rack and pinion setup. Don't worry about the details of it. That's not really the important part. The important part is that, we made a mistake, and we learned from it, and we pivoted. And pop. This was really fun. Slide. Did someone change that? Someone
Nathan.
totally changed that. But yeah, despite the full redesign, it still didn't do what we needed it to do. And this is a great case of not seeing the forest through the trees. I got so focused on the Pokeball system and to getting that to function like we wanted it to, in which it did. But what I didn't consider was the whole system, and this was only half of it, right? So we had the Pokeball that I talked about, and then there's the rover. And the whole point of the Pokeball is to deliver the rover. And because I hadn't properly managed the weight and volume budget for the entire system, this didn't fit. Like, the rocket just could not handle this much weight, could not handle this much size. And ultimately, the decision had to be the tough to call at the end of December, the end of that second drop test, had to be made to cut it and to just go to a normal parachute attached to just the rover and to not include the Pokeball at all. And so while that may sound, like a downer, like, we got through, we persevered, and, we redesigned, and it still didn't work. The point of this is not to say, we didn't get it, what we wanted done. Because ultimately, despite that, even the mistake of not managing the weight and volume budget and having to cut it, it actually ended up being one of the cooler systems I think that I've worked on in this club. There's a lot of people in this call that touched this a little bit or worked on it heavily. Actually, I think all of the mentors in some capacity worked on it, which is pretty cool. You can see in the picture down here, this was us on the second drop test. I had a ton of fun. Oh, wait, I need to show you guys the other video. Emma will appreciate this. It won't let me drag it over. There we go. Not this one. Yeah. We had fun testing the parafoil in Centennial at like 3 a.m. some night with it like strapped to a backpack on Emma's back. Yeah, no, we had a lot of fun. So yeah, despite the mistakes, despite the issues we ran into, it was a really cool project, and we learned a lot, and that at the end of the day is what we're here for. So I'm going to let you go next, Bryce. It's not going to let me do this unless you give me access.
I don't know how to give you access either.
I just requested it. It should send you an email.
I mean, Bryce could just share his screen.
Yeah, also true.
Bryce presumably has access.
I hope.
Give me 2 seconds.
Oh, wait, I have this video downloaded. I can just show it.
Oh, yeah, that works.
Yeah. I'm grabbing it now. You can start talking and I'll pull it up.
Yeah, so this is our payload from, I believe it was 2018, 2019. It was the first payload system that a lot of us had worked on that had to go inside of a rocket like this. And there were just a lot of, growing pains that we had when we tried to fit something in this small space. So the challenge was to have something move without the use of tracks or wheels, or you could, and have maybe like a points loss, which now looking back, I think we probably could have succeeded a lot better if we had done maybe the simpler thing, but we tried the harder one, and we learned a lot from it. So an important note about this video is that all of the electronics are outside of the payload on the floor, and that's when it's working pretty well. So when we tried to move them inside, it was pretty difficult to package them because a 4-inch rocket is a pretty small diameter to try to fit a lot of electromechanical components. So when we, tried to fit all of this stuff in, it was just really difficult. And we ended up making most of it work mechanically, but we, had to just throw endless hours at it because we just hadn't really learned design for manufacturing yet. So from this, we were able to take a lot of lessons forward when we did. As a student launch the next year, for example, we moved up to 6 inches instead to try to give us some more volume. We tried to coordinate a lot better between the groups just because communication wasn't super fleshed out on this project between mechanical and software and electrical. And, we learned a lot, but, starting out, you'll certainly have a lot of issues just because, you're not that experienced yet, and that's totally okay. Also, we named it Satifer because it's a combination of Satan and Lucifer, if anybody was wondering.
Yeah.
We weren't very happy with it by the end.
We were pretty unhappy with it. That's why we drew the devil on it.
Hey,
All right, Andy,
so,
you're up.
This is my slide. Here, don't play that yet, though. That's that comes later.
Okay.
So last spring, I was actually, so to preface this, Bryce and Scott sort of talked about larger projects that may not have gone as planned, but I figured I'd talk about maybe sort of a specific instance of stupidity, because I think that's the kind of thing that we all run into from time to time. And if you're doing something new, you're more likely to run into it. And I'm a second year; they're all a lot older. So maybe my problems are a little closer to the kinds of things that you guys might face.
Calling us old?
Yes.
Back in my day.
So yeah, this is a specific instance or two of stupidity. Stuff that I should have known better about. So last spring and summer I was doing a bunch of testing on a parachute system. I wanted to figure out the coefficient of drag for different reefed configurations. So the coefficient of drag essentially is just this number that relates how fast you're going to how much drag force you get off the parachute. And obviously that's important for controlling the descent of a rocket. So yeah, I was messing with different configurations for these parachutes, and I had this load cell, belonged to the club. It cost about $200 for this load cell. A load cell is essentially just a scale. It measures force. So I mean, you could use it to measure weight, but I was using it to measure the drag force on the parachute. It's the thing, the metal thing up in the top right corner there. So I mounted it to my car on the top of an 8-foot mast, and the first time I did that, I figured, okay, I'm just going to go slow, very slow, just around the neighborhood, and go down to a school parking lot. And I figured that the mast doesn't need to be very strong, right? Because I'm not going to be going very fast. And of course, I didn't, take the time to actually test the strength of the mast by like pulling on it. And I also didn't consider the fact that there might be gusts of wind. So I took a board, as you can see over here on this picture on the right, that the bottom board strapped to the top of the car. The top board is screwed with 4 deck screws to the end of the bottom board. And what could go wrong, right? Obviously, that's not going to be terribly strong. Now, you might think that the deck screws would hold, and yeah, there's some strength there, but you've got that giant lever arm on top of it. So I went down to this parking lot and was driving around, and then lo and behold, a gust of wind came along and carried away the top of the mast. The load cell was attached to the top of the mast. The load cell has a wire going to it. and the wire, was connected to the car because I was reading data off of it, and the wire got ripped out of the load cell, and there goes $200 of the club's money, which is unfortunate. So yeah, it's just like not thinking through things carefully enough. It happens, and it can cost some money. So try not to do it, but if you do, it's not the end of the world. I also did another similar stupid thing where I overestimated the strength of wood. If you play the video, I I had an aluminum rod sticking through the center of the parachute that was supposed to help stabilize it so I could get better data, and the parachute just wiggling around like that ripped the rod out of its mounting. So then I was driving along and I heard some weird noises, and then I saw an aluminum rod dangling down past my passenger window. So yeah, but in the end I got good data and everything. I did a lot of testing, but definitely made some mistakes along the way, and it's all good.
Yeah, so my thing here is also a story of just general stupidity and carelessness, and it happened literally yesterday. So the picture there is a sonar that I've been working with on my co-op. It costs about $4,500, and we're using it for obstacle avoidance on a $500,000 vehicle. So I was mounting it on the vehicle yesterday with another engineer, and we'd been working on this thing all day, so we were getting pretty tired. And we had a couple of exposed wires sitting out, and some of them were carrying vehicle power at about 30 volts. And at some point, one of them brushed one of the signal wires, and all of a sudden we can't talk to the sonar anymore. And so it turns out there's a fuse on the signal wire that blew, and we can't fix it. So the $4,500 piece of hardware was going to be useless. And unfortunately, there's other communication protocols that aren't on those fuses, so we can still talk to it and we can still do our deployment in a couple days. But for a while, it looked like this whole boat trip we had lined up in a couple days was just not going to be useful because the sonar was a brick, a very expensive brick. And again, this is just a story of pure carelessness. I just had exposed wires lying around next to things that were very voltage sensitive, and I wiggled something and they brushed momentarily. Yeah,
I think it's particularly notable that this happened yesterday. This stuff happens all the time. Like, that's not scripted. This isn't like it happened a year ago. Like, some of our examples happened like a while ago. No, this just happens.
Yeah, this was yesterday, and so I was at work all day today on a holiday fixing my stupid mistake.
Emma,
We can't hear you.
you're muted.
Oh, she's not muted in Zoom.
She's trying to talk. Her microphone's not working.
Okay. Can you try switching it to be your computer mic, maybe? Maybe it's trying to be your headset mic.
Can you hear this?
Yeah, that. If you bring that closer, you're just quiet.
All right. Yeah. So I'm gonna give you guys the scoop on the scoop. Sorry, I had to say that one. So this is the more prototypey side of things. This was also for competition rectory last year. The idea was we were collecting simulated lunar ice. So we did a bunch of research and came up with like a whole bunch of designs. The bottom left was like some soil science drill bit. So the first idea was like stick a spoon on a motor. And it felt very silly and very stupid. And so I kind of didn't try it for a long time. But we made all these like 3D printed augers. I spent a while figuring out how to model that the bottom left drill bit thingy. And eventually we went to the top left, which was like a more complicated version of the auger where it also collected it. And then we finally printed a scoop and stuck it on a motor and tried it, and it just magically worked. So that's definitely try the complicated things because they can often teach you a lot, and sometimes the complicated things are the best, but also try the ones that sound stupid and easy.
It's very common that the super simple solution is going to end up being your best bet. Complicated does not mean good, necessarily. All right. So that's the end of the presentation on this stuff. If you guys have any questions about any of the things we talked about, if you have any questions in general, you guys have an opportunity to ask those now. And if not, I will have you guys break out into your breakout room. Oh, actually, before you do that, Geneva drives. One thing I wanted to mention with that. So even if you didn't respond, as Peyton posted this message in Mechatronics General also, but even if you didn't respond to my message asking about if you wanted me to print Bryce's model or if you wanted me to print your own model of the Geneva drive, I still printed one for you. So if you didn't respond, I assumed you just wanted the model that Bryce made, the original template. So I have that. So I'm going to set another time, either this Friday or maybe it's sometime this weekend. I'm not sure yet. Another pickup time, probably. If you guys, I'll have a thing where you can say if you're coming this time, just so that I know if I should be expecting people or not. Please do come and get it. If you can't make that last time, please shoot me a PM, and I'll find a time that I can get the stuff to you guys. So I've got them already in bags. I've got the printed parts, the hardware, the tools you need. Everything's ready to go. So